The whispers began decades ago, an echo of a future yet to arrive, a future where the very fabric of warfare would be rewoven not through brute force alone, but through an unseen hand, a silent guardian, an omnipresent specter. Today, that future is not merely at our doorstep, it has taken flight. We stand at a precipice, witnessing a moment etched into the annals of strategic power, a truly historic inflection point for the evolution of U.S. air power, and, by extension, global security. The second B-21 Raider has officially graced the skies, a testament to audacious vision, relentless innovation, and an unyielding commitment to redefine the very essence of aerial supremacy. This is not just another aircraft, it is a declaration, a paradigm shift, a promise of a new era. The second test flight of the B-21 Raider is far more than a routine procedural check. It represents a monumental leap in capabilities, a validation of years, indeed decades of painstaking research, development, and engineering ingenuity. To comprehend the magnitude of this event, we must delve beyond the surface-level observations. We must peer into the intricate tapestry of its design changes, the revolutionary stealth improvements it brings to bear, and the profound strategic implications it holds not just for the U.S. Air Force, but for the intricate dance of global deterrence and the future of Northrop Grumman's legacy in defense innovation. This is where the story truly begins to unfold, where the theoretical becomes tangible, and where the aspirations of engineers and strategists coalesce into a machine of unparalleled potential. The B-21 Raider is emerging from the shadows, not to cast a visible presence, but to assert an undeniable one, reshaping the very contours of modern conflict without ever needing to be seen. The B-21 Raider, often hailed as the ghost of the future, is a moniker it earns through a synthesis of advanced materials, next-generation sensors, and an unmatched low observability profile. This stealth bomber is not merely an improvement upon its predecessors, it is a fundamental reimagining of what a strategic asset can be. It redefines modern warfare by introducing an unprecedented level of capability into the strategic landscape, pushing the boundaries of what was once thought possible in terms of penetration, survivability, and lethality in contested environments. The very concept of engagement shifts when an adversary cannot detect, track, or intercept a threat until it is far too late. This psychological advantage alone, the constant gnawing uncertainty of an unseen presence, is a weapon in itself, a silent amplifier of deterrence that resonates far beyond the physical reach of its armaments. It forces potential adversaries to reconsider their entire defensive doctrine, to expend vast resources on countermeasures that may prove utterly futile, and to grapple with the unsettling reality that their most fortified positions might no longer be inviolable. This inherent uncertainty is a powerful disincentive, a cornerstone of its strategic value. The journey to understand the B-21 Raider demands a deeper exploration. We must dissect its hidden systems, compare its revolutionary attributes to the venerable bombers of yesteryear, and ultimately grasp the profound implications this singular aircraft holds for the next era of strategic deterrence. For those who feel the pull of military aviation, for enthusiasts of stealth technology, or for anyone who contemplates the complex future of warfare, this is more than just an analysis. It is an essential narrative, a window into a future that is rapidly becoming our present. It is an invitation to witness the birth of a legend, a machine forged in the crucible of necessity and designed to safeguard an uncertain future. This is the B-21 Raider, and its story is just beginning to be told, piece by intricate piece, detail by profound detail, each revelation building upon the last to paint a picture of unrivaled capability and strategic foresight. The initial conceptualization of the B-21 Raider emerged from a confluence of strategic requirements that became increasingly apparent in the post-Cold War era. While the Beihai Spirit represented a monumental leap in stealth technology, its operational costs and the changing geopolitical landscape necessitated a new approach. The Long-Range Strike Bomber program, initiated in the early 2010s, sought to develop a highly survivable, penetrating aircraft capable of delivering conventional and nuclear payloads anywhere in the world. This new bomber had to be adaptable, resilient, and, crucially, more affordable to acquire and operate than its stealthy predecessor. It was a daunting challenge, one that required not just incremental improvements, but a fundamental re-evaluation of design philosophy, manufacturing techniques, and operational doctrines. The vision was clear, a bomber that could operate across a spectrum of conflict, from high-intensity peer-on-peer engagements to regional contingencies, ensuring that the United States maintained an undeniable strategic advantage. The name Raider itself is an homage to the Doolittle Raiders of World War II, symbolizing daring, resilience, and the willingness to project power when and where it is needed most, a direct link to a heritage of audacious aerial operations that changed the course of history. One of the most immediate and striking aspects of the B-21 Raider's second test flight is the confirmation of significant design changes. While specific details remain cloaked in secrecy, as is befitting a stealth platform of this caliber, experts and observers have been able to infer several key evolutions from public imagery and general program objectives. The most obvious, yet perhaps most complex aspect, relates to its overall aerodynamic form. The B-21 appears to present a more refined, potentially even more flattened wing-body blend than the B-2. This isn't merely an aesthetic choice, it's a meticulously calculated engineering decision aimed at optimizing stealth characteristics across a wider range of radar frequencies and angles. The smoother contours, the reduction in any sharp edges or discontinuities, and the precise shaping of its surfaces surfaces all contribute to minimizing its radar cross-section, essentially allowing radar waves to harmlessly reflect away from the source rather than returning a detectable signal. Every curve, every angle, every panel junction on the B-21 is a masterclass in low observable design, a testament to computational fluid dynamics and advanced electromagnetic modeling that has pushed the boundaries of what is geometrically possible in an operational aircraft. Beyond the visible modifications, the internal structure and material composition likely represent even more profound advancements. The B-21 is widely believed to incorporate a new generation of radar-absorbent materials, RAM, that are lighter, more durable, and more effective across a broader spectrum of threats than those used in previous stealth aircraft. These materials are not merely paint, they are often integrated into the very structure of the airframe, absorbing incoming radar energy and dissipating it as heat, rather than reflecting it back. The application of these materials and the methodologies for their integration are proprietary secrets, but their impact is undeniable. The result is an airframe that is not only aerodynamically efficient, but also electromagnetically inert, a true ghost in the machine age. Furthermore, the modular design philosophy of the B-21 is a crucial design change. Unlike previous programs, which often led to rigid, difficult-to-upgrade systems, the Raider is engineered for open architecture and future scalability. This means that as new technologies emerge, whether in computing power, sensor capability, or electronic warfare, they can be seamlessly integrated into the B-21 without necessitating a complete overhaul of the airframe. This foresight in design ensures that the Raider will remain at the forefront of technological superiority for decades to come, mitigating obsolescence and maximizing its long-term strategic value. This adaptable core is a foundational element, ensuring its enduring relevance. The stealth improvements embodied in the B-21 Raider are, without hyperbole, game-changing. They represent the culmination of decades of research into signature reduction, pushing the envelope far beyond even the impressive capabilities of its predecessor, the B-2 Spirit. When we talk about stealth, we are not merely referring to invisibility. Rather, it is a complex discipline encompassing multiple signature types: radar, infrared, acoustic, and even visual. The B-21 aims for ultra-low observability across all these domains, creating an aircraft that is exceptionally difficult to detect, track, and engage. Its advanced shaping, as previously discussed, is a primary component of its radar stealth. The flying wing design eliminates vertical stabilizers, which are notorious radar reflectors, and optimizes the entire aircraft to scatter radar energy in directions away from the transmitting source. This radical aerodynamic configuration, refined through countless hours of wind tunnel testing and computational simulations, ensures that the B-21 presents an infinitesimally small radar cross-section to hostile systems, rendering it virtually undetectable to all but the most advanced and carefully positioned sensors. This is not about being invisible, but about being undetectable in any practically useful way for an adversary, making the decision to engage an impossibility. But stealth is far more than just shaping. The B-21 integrates a revolutionary suite of radar-absorbent materials, RAM, that are fundamentally different from those used in earlier generations of stealth aircraft. These materials are not simply coatings, they are often structural components, composite matrices infused with ferrite particles, carbon nanotubes, or other exotic metamaterials designed to literally absorb electromagnetic energy and convert it into heat rather than reflecting it. This reduces the return signal to an almost immeasurable whisper, even when directly illuminated by powerful radar systems. The advancements in RAM technology mean that the B-21 can maintain its stealth characteristics across a broader range of frequencies, including those used by sophisticated low-band radars that have historically posed challenges for stealth platforms. Furthermore, the B-21 surface finishes are likely engineered with an unprecedented level of precision, minimizing panel gaps, seams, and surface irregularities that could inadvertently create radar hotspots. Each junction, each access panel, each sensor aperture is seamlessly integrated, creating an unbroken, smooth, and radar-absorbing skin that acts as an impenetrable shield against detection. This meticulous attention to detail at every scale, from the overall form to the microscopic texture of its surfaces, is what truly defines the B-21's unparalleled low observability. Beyond radar, the B-21 stealth extends to its thermal signature. Modern air defense systems increasingly rely on infrared (IR) sensors to detect and track aircraft by the heat they emit, particularly from their engines. The B-21 addresses this challenge through advanced exhaust management systems. Its engines are deeply embedded within the airframe, and the exhaust plumes are carefully mixed with cooler ambient air and directed through specially shaped nozzles. This diffuses the hot exhaust, spreading its thermal energy over a wider area and cooling it rapidly, significantly reducing the aircraft's IR signature. The result is a blurred, faint thermal imprint that is exceedingly difficult for IR sensors to lock onto, especially from distances required for effective engagement. The combination of reduced radar and IR signatures creates a multispectral stealth capability that is exponentially more challenging for an adversary to overcome. It forces them to guess, to expend precious resources on uncertain targets, and to operate in a constant state of doubt, which is a significant strategic advantage in itself. The very architecture of its internal systems is designed to minimize heat generation, from its avionics to its hydraulic systems, ensuring that every possible source of thermal emission is accounted for and mitigated, further enhancing its ghostly presence. Acoustic stealth is another critical element, particularly for missions requiring deep penetration into hostile airspace. While less critical at high altitudes, the B-21's design likely incorporates features to minimize engine noise, such as specialized inlets and exhaust designs that dampen sound propagation. Even its operational flight profile can be optimized for acoustic stealth, utilizing altitudes and speeds that make it exceptionally difficult to hear from the ground. Furthermore, the B-21 integrates cutting-edge electronic warfare (EW) capabilities that complement its physical stealth. These systems are designed not just to jam enemy radar, but to actively manipulate the electromagnetic environment, confusing and deceiving adversary sensors. It can mimic false targets, generate misleading signals, and effectively blind or overwhelm enemy air defense networks, creating corridors of vulnerability for penetration. This active stealth, combined with its passive low observability, creates a layered defense against detection that makes the B-21 exceptionally survivable in the most contested airspace scenarios. It is not merely hidden, it actively defends its hidden status, a dynamic interaction with its environment that constantly reinforces its elusive nature. The integration of advanced sensors is another pillar of the B-21's stealth and operational effectiveness. While its primary mission is to remain undetected, it must also be acutely aware of its surroundings. The B-21 likely features a suite of passive, low probability of intercept/detection (LPI/LPD) sensors that allow it to gather intelligence, navigate, and identify targets without emitting detectable signals that could compromise its position. These include highly sensitive electro-optical/infrared (EO/IR) targeting systems, synthetic aperture radar (SAR) operating in an LPI mode, and sophisticated electronic support measures (ESM) that can passively detect and analyze enemy radar emissions. These sensors enable the B-21 to build a comprehensive picture of the battle space, identify high-value targets, and even engage them with precision-guided munitions, all while maintaining its elusive profile. The ability to see without being seen, to operate within the adversary's sensor networks without being identified, is a tactical and strategic game-changer. It transforms the bomber from a blunt instrument into a precision tool capable of surgical strikes with unparalleled accuracy and minimal risk. This advanced sensor fusion capability means that the B-21 is not just an empty vessel designed for stealth, but a fully aware, highly intelligent platform, constantly analyzing its environment, making real-time decisions, and adapting to threats before they can even materialize. This autonomous and semi-autonomous operational capability is critical for its future mission sets. The strategic implications of the B-21 Raider for the U.S. Air Force are monumental, heralding a new era of global power projection and strategic deterrence. For decades, the B-52 Stratofortress has been the backbone of the bomber fleet, a testament to enduring design but limited in its ability to penetrate modern air defenses. The B-2 Spirit, while stealthy, was acquired in limited numbers, making its deployment a highly strategic and often constrained decision. The B-21 is designed to be the best of both worlds, a highly stealthy, penetrating bomber, but also one that can be acquired in sufficient numbers to form the true backbone of the future bomber force. The U.S. Air Force envisions a fleet of at least 100 B-21 Raiders, potentially more, which would provide an unprecedented level of persistent, long-range strike capability. This larger fleet size ensures that the Air Force can maintain a constant global presence, respond to multiple contingencies simultaneously, and provide an assured strike capability against even the most heavily defended targets. It is about presenting a credible threat that no adversary can ignore, a capability that ensures strategic stability through an overwhelming deterrent posture. The introduction of the B-21 fundamentally redefines strategic deterrence. Deterrence, at its core, relies on convincing a potential adversary that the costs of aggression outweigh any perceived benefits. The B-21 enhances this calculus by demonstrating an undeniable ability to hold any target at risk anywhere on the planet, regardless of how robust its defenses may be. In an era of increasingly sophisticated anti-access/area denial (A2/AD) strategies employed by peer competitors, the B-21 offers a vital counter. It is purpose-built to bypass these layered defenses, to penetrate deep into contested airspace, and to deliver precision payloads, whether conventional or nuclear, with impunity. This capability ensures that no sanctuary is truly safe, that no act of aggression can go unaddressed. The very existence of the B-21 in significant numbers forces potential adversaries to reconsider any aggressive moves, knowing that their most critical assets and command and control centers remain vulnerable. This extends not just to military targets, but to critical infrastructure, industrial capacity, and political leadership, creating a comprehensive deterrent umbrella. It ensures that the Air Force's Global Strike Command retains the ability to project credible, overwhelming force, thus preserving peace through strength. This is the essence of its strategic value, preventing conflict by making victory for an aggressor an impossibility. For Northrop Grumman, the prime contractor, the B-21 program is a crowning achievement and a testament to their unparalleled expertise in stealth aircraft design and advanced manufacturing. This program secures their position at the forefront of defense innovation for decades to come, bringing with it immense economic benefits, technological leadership, and a sustained workload for their highly skilled workforce. The B-21 is not just an aircraft for Northrop Grumman, it is a declaration of their engineering prowess, their ability to manage complex, multi-billion-dollar programs, and their commitment to pushing the boundaries of what is technologically feasible. The lessons learned from the B-2 program, particularly in manufacturing techniques and stealth maintenance, have undoubtedly informed the B-21's design, aiming for a more maintainable and affordable aircraft. This focus on lifecycle costs and operational readiness is a significant strategic objective for both the Air Force and Northrop Grumman, ensuring that the B-21 can be deployed and sustained efficiently over its projected 50-plus-year service life. The manufacturing process itself is highly advanced, leveraging digital design, advanced robotics, and potentially additive manufacturing techniques to produce the complex, low-observable airframe with unprecedented precision and efficiency. The B-21 is a testament to the symbiotic relationship between military strategy and industrial innovation, where national security needs drive technological advancement and advanced technology enables new strategic paradigms. The B-21 Raider truly redefines modern warfare, not merely through its individual capabilities, but through its holistic impact on the operational landscape. Its ability to penetrate sophisticated air defenses means that it can create effects that were previously only achievable with a high degree of risk, or not at all. Imagine a scenario where a critical, time-sensitive target deep within enemy territory needs to be neutralized. In the past, such a mission might require a massive, coordinated strike package involving multiple aircraft types, electronic warfare support, and fighter escorts, all facing significant attrition risk. The B-21, however, can execute such a mission with a far smaller footprint, potentially as a single platform, relying on its stealth and advanced systems to navigate safely to the target, deliver its payload, and return. This changes the risk calculus entirely, making high-value, deep strike missions far more feasible and dramatically increasing the cost-benefit ratio for decision-makers. It enables a surgical approach to warfare, allowing for precise and decisive actions without necessarily escalating a broader conflict. The implications for limiting collateral damage and preserving civilian lives are profound, as precision targeting and reduced exposure risk minimize the broader footprint of conflict, enabling a more controlled and targeted application of force when it becomes absolutely necessary. The concept of unmatched low observability is central to the B-21's revolutionary nature. It's not just about reducing a radar signature, it's about making the aircraft effectively invisible to every known and anticipated sensor system that an adversary might deploy. This involves a multispectral approach, targeting radar, infrared, acoustic, and even optical signatures. Its advanced materials, as previously touched upon, play a crucial role. These aren't just off-the-shelf composites, they are cutting-edge metamaterials engineered at the molecular level to manipulate electromagnetic waves in unprecedented ways. These materials can be designed to absorb radar energy across a broad spectrum of frequencies, to refract light to reduce visual detection, or even to dissipate heat more efficiently to minimize infrared signatures. The internal architecture of the B-21 is also meticulously designed to reduce observability. Its engine inlets and exhausts are carefully shrouded and shaped to prevent radar reflections from the spinning turbine blades, which are often significant radar reflectors. Internal weapons bays, which open only for brief moments to release munitions, ensure that external stores do not compromise the aircraft's stealth profile. Every cavity, every opening, every antenna is either flush-mounted or retractable, maintaining the aircraft's pristine, low-observable outer mold line at all times. This comprehensive approach to signature reduction means that the B-21 is not just stealthy in specific scenarios, but robustly stealthy across a wide range of operational environments and against a diverse array of threats. The next-gen sensors integrated into the B-21 are not merely upgrades, they represent a fundamental paradigm shift in situational awareness and targeting capabilities. Traditional bombers often rely on external intelligence sources and pre-planned flight paths. The B-21, however, is designed to be an intelligent, autonomous platform capable of real-time adaptation and decision-making. Its passive sensor suite includes advanced electro-optical/infrared (EO/IR) systems with unprecedented resolution and range, allowing it to detect, track, and identify targets from immense distances without emitting any detectable energy. Its low probability of intercept radar can generate high-resolution synthetic aperture radar (SAR) imagery, creating detailed maps of the terrain below and identifying targets with pinpoint accuracy, all while minimizing the risk of detection by enemy electronic intelligence systems. Furthermore, the B-21 is expected to integrate advanced electronic support measures (ESM) that can passively listen to enemy communications and radar emissions, providing invaluable intelligence on the adversary's order of battle, locations, and intentions. This comprehensive multispectral sensor fusion allows the B-21 to build a real-time 360-degree picture of its operational environment, enabling it to navigate safely, avoid threats, and strike targets with unparalleled precision and autonomy. This level of integrated intelligence gathering and targeting capability makes the B-21 not just a bomber, but a highly sophisticated reconnaissance and intelligence platform in its own right, further enhancing its strategic value and versatility. Is the B-21 truly the ghost of the future? The evidence suggests an emphatic yes. This designation stems from its unique ability to operate unseen, to exert influence without revealing its presence. In the psychological landscape of modern warfare, the unknown is often more terrifying than the known. An adversary facing the B-21 must contend with the unsettling reality that their most critical assets, their command centers, their logistics hubs, and their strategic deterrence are perpetually vulnerable to an attack they cannot predict, detect, or defend against. This psychological burden alone is a powerful disincentive to aggression. It forces potential adversaries to expend vast resources on defensive measures that may ultimately prove futile, diverting their attention and capabilities from offensive actions. The ghost metaphor extends beyond mere invisibility. It encapsulates the B-21's ability to sow doubt, create paranoia, and fundamentally undermine an adversary's confidence in their own security. It represents the ultimate asymmetric advantage, a tool that can destabilize an enemy's will to fight before a single weapon is even deployed. It is a silent whisper of overwhelming power, a constant reminder that the rules of engagement have been irrevocably altered. To truly appreciate the B-21's revolutionary nature, we must break down its hidden systems. These are not merely components, they are a network of integrated technologies working in concert to achieve unprecedented levels of stealth and capability. Beyond the physical shaping and RAM, the B-21 likely employs Advanced Active Electronically Scanned Array (ASA) for its radar and electronic warfare systems. These AASAs can perform multiple functions simultaneously, such as targeting, navigation, and jamming, all while emitting signals that are difficult to detect or pinpoint. The power management systems are equally crucial, ensuring that all these energy-intensive systems can operate efficiently without generating excessive heat or electromagnetic signatures that could compromise stealth. Its flight control systems are highly sophisticated, enabling the pilot, or potentially an autonomous system in future iterations, to precisely maneuver the inherently unstable flying wing design, all while optimizing for stealth and mission effectiveness. The mission system's architecture is expected to be highly networked, allowing for seamless communication with other stealth assets such as the F-35 and future unmanned platforms, creating a truly integrated system of systems that multiplies the effectiveness of each individual platform. This distributed, networked warfare capability is a cornerstone of future conflict, and the B-21 is designed to be a central node within this interconnected battle network. Comparing the B-21 Raider to previous bombers illuminates the dramatic evolution of strategic air power. The venerable B-52 Stratofortress, a true workhorse, has served for over 60 years, delivering massive conventional payloads from standoff distances. However, its large radar cross-section and relatively slow speed make it highly vulnerable in contested airspace. The B-1B Lancer, a supersonic variable sweep wing bomber, offers speed and range but lacks the deep penetration stealth capabilities needed against modern air defenses. The B-2 Spirit represented the first true leap into stealth bombing, proving the viability of the flying wing concept and low observability. However, its limited production run, only 21 aircraft, and extremely high operational costs restricted its widespread deployment. The B-21 addresses these limitations head-on. It leverages the B-2's stealth pedigree but enhances it with next-generation technologies, aiming for even lower observability across a broader spectrum. Crucially, it is designed for greater affordability in both acquisition and maintenance, enabling the U.S. Air Force to procure it in larger numbers. This mass production, combined with its advanced capabilities, means that the B-21 will not be a niche asset, but the cornerstone of global strike operations for the coming decades. It is the synthesis of lessons learned from all its predecessors, refined and reimagined for a future defined by complex and sophisticated threats. The B-21 is specifically designed to operate in an environment of advanced integrated air defense systems, IDADs, that were not fully developed when the B-2 was conceived. These modern IDADs combine networked long-range radars, advanced surface-to-air missile SAM systems, and sophisticated electronic warfare capabilities to create highly lethal no-fly zones. The B-21's ultra-low observability and advanced electronic warfare suite are tailored precisely to overcome these challenges, ensuring that it can penetrate these denied areas and deliver its payloads effectively. Its ability to communicate securely and stealthily with other assets, such as reconnaissance aircraft or fifth-generation fighters, allows for dynamic mission adjustments and target retasking, further enhancing its adaptability and survivability. This network-centric approach to warfare is a critical differentiator, enabling the B-21 to operate not as a solitary ghost, but as an integral part of a larger, intelligent, and highly coordinated force, multiplying its impact exponentially. It represents a paradigm shift from individual platform excellence to integrated force effectiveness, where the sum is far greater than its individual parts. What does all of this mean for the next era of strategic deterrence? It means that the fundamental equation of power projection is being rewritten. In an increasingly multipolar world where potential adversaries are investing heavily in advanced military capabilities, maintaining a credible deterrent is paramount. The B-21 provides that credibility by making it clear that no amount of defensive investment can truly shield an aggressor from retaliation. It ensures that the U.S. and its allies can hold any target at risk, anywhere in the world, at any time, with precision and overwhelming force. This capability underpins the extended deterrence strategy, reassuring allies that they are protected and discouraging adventurism from rivals. The Raider acts as a powerful disincentive to regional conflicts, nuclear proliferation, and violations of international norms. Its very existence projects strength and stability not through overt displays of force, but through the silent, omnipresent threat of its unseen power. This is a subtle yet profound shift in strategic messaging, moving from "we can destroy you" to "we can and will reach you, and you won't even know we're there until it's too late." This quiet assurance is perhaps its most potent contribution to global security. The B-21's role in future conflicts extends beyond direct strike missions. It is also a critical platform for strategic reconnaissance, intelligence gathering, and even acting as a command and control node for swarms of unmanned aerial vehicles, UAVs, in contested airspace. Its ability to operate undetected deep within enemy territory makes it an ideal platform for collecting vital intelligence, assessing battle damage, and providing real-time targeting data for other assets. This multi-mission capability further enhances its value and makes it an indispensable asset in the complex, data-driven warfare of the 21st century. The modular, open architecture design ensures that these capabilities can be continually upgraded and expanded as technology evolves, keeping the B-21 at the cutting edge for its entire service life. This foresight in design is a testament to the comprehensive strategic thinking that went into its development, recognizing that future warfare demands adaptability and continuous evolution, not static capabilities. For those truly passionate about military aviation, stealth technology, or the very future of warfare, the B-21 Raider is a captivating subject. It represents the pinnacle of human ingenuity applied to the most challenging of military problems: how to achieve superiority in an increasingly complex and contested battlespace. It is a story of engineers pushing the boundaries of material science, aerodynamic theory, and computational power. It is a story of strategists envisioning a future where deterrence is upheld through technological dominance. It is a story of a nation investing in the capabilities necessary to safeguard its interests and protect its allies in a volatile world. This is not just an aircraft, it is a symbol of technological prowess, a testament to strategic foresight, and a powerful instrument for shaping the future of global security. The B-21 Raider is here, and its impact will resonate for generations, echoing the silent, unseen power that defines the very essence of its existence. Its silent flight heralds a new dawn, or perhaps a new twilight, for the art of warfare. The second flight of the B-21 Raider, therefore, is more than a mere technical milestone. It is a profound declaration, a bold statement about the future trajectory of global power dynamics. As we reflect on this achievement, it becomes clear that the Raider is not just an incremental improvement over previous designs. It embodies a philosophical shift in how nations conceive of and prosper prosecute warfare. It moves beyond the visible display of force to a more subtle yet utterly devastating capability to project power with impunity. The silent passage of the B-21 across enemy skies represents a new form of psychological warfare, an intangible yet ever-present threat that undermines the very confidence of an adversary's defenses. This psychological aspect, the nagging uncertainty of detection, is perhaps as potent as any warhead it might carry. It creates a constant state of vigilance and fear, knowing that the unseen hand of retribution could strike at any moment, from any direction, against any target, however protected. Consider the emotions of a soldier, a radar operator staring at a screen that should be teeming with blips, yet remains stubbornly blank, even as intelligence suggests an intrusion. The frustration, the gnawing doubt, the fear of the unknown. Or the opposing commander, faced with a strike that came from nowhere, leaving devastation in its wake, and no trace of the attacker. This is the human element subtly woven into the fabric of the B-21's capabilities. It's not about direct confrontation, but about altering the battlefield so fundamentally that the will to confront is eroded. The B-21 does not just target infrastructure, it targets morale, it targets strategic confidence, it targets the very belief in one's own defensive prowess. This is a nuanced yet powerful application of psychological pressure, an inherent part of its design philosophy. It creates an asymmetry, not just in technology, but in the very psychology of conflict, granting the operator a profound advantage even before weapons are deployed. The precision offered by the B-21's advanced targeting systems also has a direct impact on the soldier on the ground. When strategic targets can be neutralized with surgical accuracy, it reduces the need for broader, more destructive campaigns that often carry significant human costs, both for combatants and civilians. The ability to minimize collateral damage and to strike only the necessary objectives means that future conflicts, when unavoidable, can be waged with a higher degree of discrimination and ethical consideration. This is a silent mercy in the grim calculus of war, a capacity that saves lives not just through deterrence, but through the precise application of force when deterrence fails. It speaks to a commitment to precision and responsibility, understanding that the tools of war, however potent, must be wielded with profound care. The B-21 is therefore not just a weapon of destruction, but an instrument designed to enable a more constrained and disciplined approach to conflict, minimizing the chaotic spread of violence. The material science behind the B-21's stealth is a narrative unto itself. We are talking about advancements that transcend conventional understanding. Imagine composites so precise, so intertwined, that they absorb radar waves like a sponge absorbs water. Picture coatings that actively adapt to environmental conditions, adjusting their electromagnetic properties to maintain optimal stealth in varying climates and against different sensor types. These are not futuristic pipe dreams, these are the realities being engineered into the B-21. Research into metamaterials, which possess properties not found in nature, has likely played a crucial role. These engineered materials can bend electromagnetic waves in specific ways, guiding them around the aircraft or absorbing them with unprecedented efficiency. The durability of these materials is also a critical factor. They must withstand extreme temperatures, harsh atmospheric conditions, and the stresses of supersonic flight, all while maintaining their stealth integrity over decades of service. This necessitates revolutionary approaches to material bonding, structural integration, and surface maintenance, ensuring that the ghostly exterior remains unblemished and effective through countless missions. The manufacturing process of the B-21 itself is a marvel of modern engineering. Northrop Grumman has invested heavily in digital engineering, utilizing advanced simulations and virtual prototyping to design and optimize every aspect of the aircraft before physical production even begins. This digital thread allows for rapid iteration, reduces design errors, and streamlines the manufacturing process. Robotics and automation play a significant role in assembling the complex, low-observable airframe, ensuring precise tolerances and consistent quality that are paramount for maintaining stealth. The concept of design for manufacturability has been central, aiming to make the B-21 not just technologically superior, but also more efficient to produce and maintain than its predecessors. This industrial prowess, combining cutting-edge science with advanced manufacturing techniques, is as much a part of the B-21's story as its visible capabilities. It ensures that the required numbers can be built and sustained, making its strategic impact a widespread reality rather than a limited boutique capability. The ability to scale production while maintaining exacting standards is a testament to the industrial base supporting this program. The B-21's role in deterring near-peer adversaries is particularly significant. Nations like China and Russia have invested heavily in sophisticated anti-access/area denial capabilities, aiming to push U.S. forces further from their borders and deny them freedom of maneuver. These A2AD networks are complex, combining long-range radars, advanced surface-to-air missiles, anti-ship missiles, and fighter aircraft, all networked together. The B-21 is specifically designed to dismantle these networks, to penetrate deep within them, and to hold at risk the very assets that form their backbone. By demonstrating the ability to neutralize key command and control nodes, radar sites, and missile launchers, the B-21 undermines the entire A2/AD strategy, effectively rendering these vast investments vulnerable. This capability ensures that the U.S. and its allies can maintain freedom of navigation, project power when necessary, and prevent potential adversaries from establishing regional hegemony through military coercion. It is a direct and forceful answer to a growing strategic challenge, a precise scalpel against a broad, integrated threat. Furthermore, the B-21 represents a significant step towards networked warfare and integrated battle management. It is not intended to operate in isolation. Rather, it is envisioned as a central node in a broader system of systems, seamlessly communicating and coordinating with other stealth platforms like the F-35 and F-22, as well as future unmanned aerial vehicles and satellite assets. This interconnectedness allows for real-time information sharing, dynamic targeting, and coordinated strike operations, multiplying the effectiveness of the entire force. Imagine a B-21 penetrating deep into enemy territory, identifying a critical target, and then relaying that information to a swarm of autonomous UAVs that can then execute a precision strike, all while the bomber remains undetected and focused on its next objective. This level of synergistic capability transforms warfare into a highly efficient, distributed, and adaptive process, placing an unprecedented burden on any adversary attempting to defend against it. This is the future of conflict, where intelligence, precision, and stealth merge into an unstoppable force, a digital ghost in the machine age. The ethical considerations surrounding such advanced weaponry are also profound. The B-21, with its ability to conduct surgical strikes from an undetected position, raises questions about accountability, the nature of targeted killing, and the potential for reduced thresholds for engaging in conflict due to perceived invulnerability. While proponents argue that precision weapons minimize collateral damage and save lives, critics often point to the dehumanizing aspect of remote warfare and the potential for a clean war that makes conflict easier to initiate. These are complex debates that will continue to evolve as technology advances. However, the B-21, as an instrument of strategic deterrence, primarily aims to prevent war by making its cost prohibitively high for any aggressor. Its very existence is intended to foster peace through strength, ensuring that the horrors of large-scale conflict remain confined to the realm of theoretical contemplation rather than becoming a stark reality. The ethical imperative in this context lies in its capacity to deter, to ensure that its power is so overwhelming that it prevents the need for its active deployment in anger. It is a powerful shield, even if it has the capacity of a sword. The longevity of the B-21 Raider, designed for a 50-year service life, underscores its foundational role in future defense strategies. This means that generations of airmen will operate and maintain this aircraft, adapting it to unforeseen threats and integrating future technologies. Its open architecture and modular design are crucial for this longevity, ensuring that it can evolve as rapidly as the geopolitical and technological landscape changes. This forward-thinking design philosophy represents a significant departure from past programs, which often struggled with obsolescence within a few decades. The B-21 is built to last, to adapt, and to remain at the cutting edge, a true enduring asset for national security. This sustained relevance means that the initial investment, while substantial, will pay dividends for decades to come, providing a consistent and reliable strategic capability across multiple administrations and through various geopolitical shifts. It is an investment in the long game of global security, a foundational pillar for future strategic stability. In conclusion, the second test flight of the B-21 Raider is not merely a technical event, it is a profound declaration of intent. It marks a historic moment, signaling a dramatic evolution in U.S. air power and the very nature of modern warfare. This stealth bomber, with its advanced materials, next-gen sensors, and unmatched low observability, truly redefines what is possible. It is the embodiment of the ghost of the future, a silent, unseen force designed to deter aggression, protect national interests, and ensure global stability for generations to come. The B-21 Raider represents the pinnacle of technological innovation, strategic foresight, and the unwavering commitment to maintaining a decisive advantage in an increasingly complex world. Its hidden systems, its comparison to previous bombers, and its implications for the next era of strategic deterrence paint a clear picture. The B-21 is not just an aircraft, it is a foundational element of tomorrow's security architecture. For those who understand the intricacies of military aviation, the power of stealth technology, or the enduring challenges of future warfare, the B-21 Raider stands as a monument to ingenuity, a silent sentinel poised to shape the future. Its shadow, though unseen, will loom large over the strategic landscape, a perpetual reminder of its unseen power and its profound purpose. The future of strategic air power has arrived, and it is cloaked in the silence of the Raider. Fade in the subtle, low hum from the beginning, letting it grow slightly before fading to silence.